Actually, today we have the heart mechanical activity and the cardiac cycle. So it's a kind of a normal topic that we can always cover at a free time. And therefore, today we are going to have these objectives. First, we're going to check on the relationships between electrical, mechanical, and pressure cycle of the heart, how pressure changes are generated, and how pressure changes open and close valves. The heart sounds, the pressure, volume, and loop. So the first thing we're going to do is on cardiac cycle. First thing that you need to know, this is the sequence of events from one heartbeat to the next. Its frequency, heart rate. Duration, we can say, determined by heart rate. At 72 beats per minute, that is always at a second of 0.83 seconds. So within 72 beats per minute, you can rate every cardiac cycle range 0.83 per second. It's always coordinated by electrical impulses that are produced by specialized cardiac cells. Cardiac cycle, 3 cycles that you need to know: electrical, mechanical, volume, and pressure. When you talk about the electrical cycle, it is always represented by ECG, electrocardiogram. Then the mechanical cycle, we'll check on that, also the blood frequency and blah blah blah. We still have on volume, pressure, and changes cycle. So let's start with the mechanical cycle. Here you're gonna see it. So this is the physical translation of the effect of the electrical activity of the heart. The impulse results in events that lead to actin-myosin interaction. So when you talk about the actin-myosin, these are the proteinous element of the muscle cells. They help during the contraction, relaxation of the muscle tissue. So at most, the most important aspect of this is that the actin and myosin, we have the short ones and the thick ones. They normally contract, rub over each other, friction helps over, and then they pull each other for contraction takes place. That is the mechanical cycle. And within the same mechanical cycle, you have the diastole and systole. Diastole, we talk about relaxation. Systole, we talk about contraction. Volume and pressure change cycle. So the volume of blood that enters a compartment, that is heart chamber or blood vessels, results in an increase in pressure in that compartment. So the same events occur in the left and the right side, but pressures are lower on the right sides. So contraction of the myocardium generates pressure changes which result in movement of blood. Blood flows from an area of high pressure to an area of low pressure unless flow is blocked by a valve. So what I'm trying to say is simple. The valves exist in the heart and the veins. Most probably the valves in the heart, they protect the chambers of the heart from receiving what we call the backflow of blood. While the blood which are flowing on the veins, they also protect the veins from the backflow of the blood. So instantly, when we have systole, I say that's contraction. And normally, contraction will initiate pressure from high pressure to flow on the chamber with no pressure, that is low pressure. So contraction of the myocardium will generate pressure changes which result in movement of blood from areas where there is high pressure due to contraction and move where there is low pressure, that is where there is diastole. That is what I need to know. So when the ventricle contracts, like especially the left ventricle that contracts to pump blood to the whole part of the body, when that happens, the contraction will increase the pressure in that ventricle, and then after that, the blood will flow to a region of low pressure, that is atrium, and in the same series, the blood will now have moved from the ventricular high pressure to low pressure, that is auricles or the atrium. And from the that is if it is necessary, but at most the blood normally first flow to the auricles, then they flow into the ventricles, then through the ventricle they go to the desired place, because the contraction in the ventricle will increase the pressure of the blood flowing into the lungs, that is through the pulmonary artery, and into the other part of the body through the main artery, that is aorta. So we have basic phases of cardiac cycle. We have the ejection, contraction, feeling. So I wanted to understand this. Systole begins when there is contraction. Systole is just similar with contraction, and it normally ends when ejection ceases. That is, it's supposed to have contraction then ejection. So when the ejection ceases, we end systole and we start diastole. So systole will start contract the muscles, and then the blood will be pushed to the next level or chamber, and then it will stop. Then immediately the blood is pushed to the next chamber, diastole starts, and that means that the diastole begins when ejection ceases, when the blood has been pushed to the next chamber. So as ventricle relax and filling occurs, that is what is next. So events of the cardiac cycle, I want you to understand according to what you're able to see from your end. This is a diagrammatic presentation of what is there. First of all, we have events of the cardiac cycle, and we have like 5 chambers. We have processes, that is ventricular feeling, atrial contraction, isovolumetric contraction phase, ventricular ejection phase, and isovolumetric relaxation. So let's start with the ventricular feeling. During the ventricular feeling, to mean that blood from the all part of the body fills the ventricle. Blood from the lung also comes into the ventricle. So both ventricles are filling at the same rate. All part of the body falls into the ventricle via the vena cava, that is both superior and inferior, while blood from the lungs also come into the ventricle via the pulmonary veins. So we'll have the ventricular feelings. So during the atrial contraction, immediately the ventricles are full, we have atrial contraction. Atrial contraction will also help to necessitate the filling of ventricle, because beneath the atrial we have the ventricle. So when the atrial contracts, the ventricles get filled. So starting from let's talk about the right atrium. The right atrium, it will contract, and then the right ventricle will be filled. Similarly, when the left atrium will contract, what will have without the left ventricle will also be filled. Then we'll have isovolumetric contraction phase. At this stance, both the left and the right ventricles will be pushed at once. That is what we refer to iso. Iso means both of them at once. So isovolumetric contraction phase, it will initiate a pulse, which will initiate a pressure that will now force a contraction rhythm to be generated from the ventricle, resulting to outward pressure that releases the blood off from the left and the right ventricle. And then at later handle, we have ventricular ejection phase. So after that contraction is initiated, the ventricle will eject the blood. So when the ventricular ejection phase is initiated, ventricular ejection phase, the ventricle will eject the blood, and on the right ventricle to move to the lungs for oxygenation, and then from the left ventricle to move to all part of the body. Then we have isovolumetric relaxation. At this phase, there is relaxation in the atrium. So when the ventricle relaxes, the atrium relaxes, the blood now comes back from where it has been pushed to go. They restore the aorta. So that's a complete circle. So the circle starts from ventricular feeling and end at isovolumetric relaxation, or what we call the earlier distal. So when you classify them based on the 3 model of phase, we have the ventricular feeling, ventricular systole, and earlier diastole. So we have the 5 phases of mechanical circle. Don't forget those which I've mentioned. Then now talking about this, we have another story here. So pressure and outflow of left ventricle, that is what you want to check. And here we have ventricular feeling, isovolumetric contraction, ejection, and they are arranged in terms of duration, which each of them take. Then the valves which are associated, like for ventricular feeling, we have mitral valves and tricuspid valves, which open to pulmonary vein and aorta. The atrium veins, aortic veins and the pulmonary vein. That is what they open to. That is mitral valve and the tricuspid valve. So we have another case here, isovolumetric contraction. In this case, duration 0.05 seconds. Remember, total of these until about 0.83 seconds. So we have an inlet valve which closed and outlet valve at the same time. During isovolumetric contraction, it closed. Then we have an ejection phase. During ejection phase, the duration is 0.3 seconds. Then we have an inlet valves closed, then outlet valves open. So we also have as a isovolumetric relaxation duration 0.08 seconds. So when you add all this one, we'll have a complete circle or complete cardiac circle, where that is very important. So the same image which is following represent the same. So at your own initial time, you can come and pause at this moment, internalize all the same, get to know when it's systole and how long it takes, diastole and systole again. That is finalizing the cardiac cycle. So these videos are always relapsing in YouTube. At your free time, you can come and scroll over medical students, and right now you'll find these videos. Let's talk about diastole. During the diastole, we have ventricular feeling, and in the ventricular feeling, we have the early and the late phase. So early phase, we can also call it as rapid phase, and then during late phase, we call it slow phase. Now, the duration of systole is more fixed than diastole. So when the heart rate increases, diastole is shortened than systole, because systole, I've said, is more fixed than diastole. So to mean systole remains fixed, but what is changing or variable is diastole. So when the heart rate is changed, diastole is normally shortened or is increased either way. So let's talk about the ventricular feeling which occurs in diastole. Up to 180 beats per minute with ample ventricular rate feeling is adequate, like cardiac output per minute is increased by an increase in rate of the heart. So at very high heart rate, feeling is compromised, cardiac output per minute falls, and symptoms of heart failure starts to develop. Then we also have late feeling. During this, the function of atria as primers. So first of all, during late feelings, blood normally flows. The blood normally flows, and from your reading you can see what is expressed. It flows continuously from the great veins into the atria. That is during what we refer to as the late feeling. 80% of the blood flows directly through the atria into the ventricles even before the atria contracts. And then during the atrial contraction, usually, which causes an additional 20% filling of the ventricles, when it takes place, therefore, atria will simply function as premia. That is where the word premia comes in. So atria will take place as premia pump that increase the ventricular pumping effectiveness as much as 20%. So let's talk about the function of ventricle as a pump. Number one, filling of the ventricle. So function of ventricle as a pump, we have number one, filling of the ventricles. So after systole is over, ventricular pressure falls again to their low diastolic values. Then the moderately increased pressure that have developed in the atria during ventricular systole immediately push the atrioventricular valves open and allow blood to flow rapidly into the ventricle. This is period of rapid filling of the ventricle. I hope you are all good up to there. Now, it always lasts a third of diastole. So let's check on the mid-distal, the mid-distal or diastasis. The mid-distal is also called diastasis. During the mid one-third of distal, only a small amount of blood flows into the ventricles. And during the last one-third of the diastole, the atria contract and give an additional thrust to the inflow of blood into the ventricle. This accounts for 20% of the filling of the ventricle during each cardiac cycle. So increased heart rate and diastole, that is what is represented by there. You can be able to see from your hand, we have rest, that is 60 beats per minute, and then we during strenuous. So these are what happens when we have rest and when we have strenuous exercise. So during rest, I've said 60 beats per minute, and then during strenuous exercise, we have 180 beats per minute. You can see as indicated by the second, that is 0.66 and 0.34 seconds, and that is that. So let's talk about emptying of the ventricles during systoles. Period of isovolumic contraction. At this moment, immediately after ventricular contraction begins, the ventricle pressure rises rapidly, causing the atrioventricular to close, and an additional 0.02 or 0.03 second is required for the ventricle to build up and sufficient pressure to push the semilunar, or what we call the aortic and pulmonary valves, open against the pressure in the aortic pulmonary artery. So during a isovolumetric contraction state, during this period, contraction is occurring in the ventricles, but there is no emptying, so the tension is increasing in the muscle, but little or no shortening of the muscle is occurring, which is not always normal. So period during the ejection, after all this, when the left ventricular pressure rises slightly above 80 millimeters of mercury, the right ventricular pressure slightly above the 8 millimeters of mercury, the ventricular pressure pushes the semilunar valves open, and immediately blood begins to jet out of the ventricle at 70% fast, then 1/3 of the period of ejection. Period of rapid ejection, that is over 30% emptying during the next 2/3. That's a period of slow ejection. So let's talk about the period of isovolumic state. So during the period of isovolumetric relaxation, or what we call the isometric, at the end of the systole, ventricular relaxation begins suddenly and allowing both the right and the left intraventricular pressure to decrease rapidly. So the elevated pressure in the distended large arteries that have just been filled with blood from the contracted ventricle immediately push blood back toward the ventricle, which is now the aortic and pulmonary valves closed. For another 0.03 or 0.06 seconds, the ventricular millimeter continues to relax and the ventricular volume does not change. So that is what we refer to as isovolemic or isometric relaxation. And during this period, the intraventricular pressure decreases rapidly back to their low diastolic level. So the atrioventricular valves open to begin a new cycle of the ventricular pumping. That is all about that, but still have the ventricular volumes like the end diastolic volume, the stroke volume output, end systolic volume, ejection fraction. All those ones are very important and significant when you know. So we have another subtopic called stroke volume. During stroke volume, ventricular stroke volume is the difference between the ventricular and diastolic volume and systolic volume. The SV or the stroke volume is equivalent to EDV or minus ESV. So in normal heart, the stroke volume is the same as the blood ejected in the aorta during systole volume. So ejection fraction is another thing. So it is the fraction of blood ejected by the ventricular relaxation or relative to its filled volume. Like the EF or ejection fraction is equal to the SV or equal to EDV. So you can just proportionally relate the correct. So the sum of ventricular volumes are, that is what you see. Then you have all these which are necessary for the next class. If it is there, you can be okay. And then we check on jugular venous pressure. Very important if you just maintain your cool stance. So the C waves occurring when the ventricle begin to contract, the V waves occur toward the end of the ventricular contraction. So the same is in that image. We still have heart sound like first out, the lab, and the second sound, the dab. Then the third sound, which is concerned with the inrush of blood during rapid ventricular filling. And then the fourth third sound, atrial contraction at all. So that is that. So let's call this one for today, and then we shall check on the remaining part of this one. And then before everything is done, let's appreciate the lesson of today as we call it off. Thank you for presenting today. We shall continue from venous pressure and venous return at free time. Thank you so much and be blessed, right? Have a nice time.